Okay, in this video, we're going to talk about how to draw molecules on paper using what we call Lewis structures. For this, you're going to need something to write with, you're going to need something to write on. A periodic table may be helpful because we do need to determine the number of valence electrons that an atom has. Once you have those things ready, let's get started. Okay, so Lewis structures are how we show molecules on paper. Now, they do a good job at showing what they're good at showing, right? So they show the connectivity of each atom. So what atom is connected to this atom, which connected to that. It's good at showing how the electron pairs are shared by the atom, so showing bonds. It's also good at showing where unshared electron pairs are, so what we call lone pairs. Okay, so it's good at showing like the relative positions of the atoms and where the electrons are in the molecule generally. Now, they aren't perfect. So what they don't show is they don't show anything in 3D. This is something I see a lot whenever we ask a question about this. I'll draw a Lewis structure and people will think that the bond angles are 90 degrees because they're drawn top, bottom, left, and right. Instead of in 3 dimensions, where, as we'll go over in a later video, electrons will try to spread out as much as they can, and the angles are almost never 90 degrees. Right? So it doesn't show 3-dimensional shape. It doesn't show bond angle. It also won't show you the distribution of electrical charge in a molecule. So it won't show you whether the molecule has a positive side and a negative side, or what's called being polar. We'll cover how to do that a little bit later. Okay, so the way we're going to go about drawing these is we're going to go through a set of rules. So the first rule, whenever you want to draw a Lewis structure, is you add up the total number of valence electrons that molecule has. You will draw exactly this amount of electrons in your structure, whether they're dots or dashes or whatever we're going to use. We're going to use dots mostly. Okay, so the total number of valence electrons is the number that you shall draw. You shall not draw more. You shall not draw less, but only the exact number prescribed. Then after you figure out how many electrons you need, we're going to make a skeleton. All right, so we're just going to sketch a kind of prototypical skeleton. We're going to put the least electronegative atom in the middle, except for hydrogen, because hydrogen only forms one bond. And every other atom will go off of that central atom. Couple of things you may want to use to help you. Symmetry. As much as physically possible, simple molecules want to be symmetric. Right, so use that to your advantage when making a skeletal structure. And sometimes you'll find out after you go through the process that skeleton didn't work. That's okay. All you have to do is just play around with the structure a little bit more, and eventually you'll find something that works. And the more you do this, the more you'll kind of intuit how things will actually generally structure themselves, and it will go a lot faster as you do more and more of these. Right, so add up valence electrons, sketch a skeleton. Now we're going to start putting in electrons. What we're going to do is we're going to put one pair of electrons between each of the atoms that we have connections for in our skeletal structure. This represents a single covalent bond. So we put those pairs in, and then we subtract the number of electrons we used from the total we have to draw. After we do that, we then start putting lone pairs or unpaired electron pairs, so only on the outer atoms, until those outer atoms obey that octet rule. Now keep in mind, hydrogen only needs 2 electrons, so once it forms its bond, it's done. It will never get any other dots. Everything else, though, put electrons around the center until everything else has 8. If you've put electrons around the center and you have extra electrons left after you subtract them from your total, then those electrons go on the center atom as lone pairs. Once you've done all that, check to see that the atoms obey the octet rule. Okay, so electrons all around the outside. If you use them all up, check the octet rule. If you still have some left over, put them on the center. Now, there are going to be a couple of problems when you draw these molecules that will disobey the octet rule. First thing you're going to look at is sometimes when you do this, your center atom's going to have too many electrons, right? So it'll have 10 around the center instead of having 8. When you do this, go back and double check that you counted the electrons correctly in the first place, right? If you counted them correctly, go back, double check your structure, and if that still doesn't work, erase your structure and try drawing it a different way. Eventually, you'll find a way that will work. This is usually not a problem you have unless you misadd it. So that's usually the most common way you'd have more in the center. Now, the other thing that you'll have, and this will happen very frequently, is you put all of your electrons in, and your center atom doesn't have 8, it has less than 8. If it has less than 8, then what you do is you form a double or triple bond. So you erase one of the lone pairs from the outer atom, and you then put it in the middle to make a double or triple bond between the center atom and that atom. Generally, whenever you form a double or a triple bond, you want to use your sponge elements whenever possible because sulfur, phosphorus, oxygen, nitrogen, and carbon are going to be the ones most likely to form double bonds. Fluorine will never, ever, ever form a double bond. Chlorine, if it's on the outside, will almost never form a double bond. If you do those, you're doing it wrong. Try again. So what we'll do is we'll do an example. And the example we'll do is formaldehyde H2CO. So first thing I want to do is I'm going to take out my periodic table. We're going to add up the total number of valence electrons in this molecule. So hydrogen is in group 1, which means it has 1 valence electron. So there are 2 of them, so 1 plus 1. Carbon has 4. Oxygen has 6. So 1 plus 1 plus 4 plus 6 is 12. I get 12 electrons to put in this structure, no more, no less. Second step, we're going to draw our skeleton. Least electronegative atom in the center except for hydrogen. Now, as a good rule of thumb, if you have carbon in your molecule, carbon will almost always be the center atom. And if you have multiple carbon atoms in your molecule, you're almost always going to form a chain of carbon that's that length or somewhere around that. So I'm going to put carbon in the middle, and then I'm going to put oxygen on one side, hydrogen on other sides, top, bottom, left, and right, it doesn't matter. I'm just going to put oxygen on the top and hydrogen's on the side, and I'll leave the bottom kind of empty. Doesn't matter where you put them, though, as long as each element has its own side to itself. Now I'm going to put dots in the middle between the carbon and oxygen, the carbon, hydrogen, the carbon, hydrogen. That's 6 dots. I'm going to subtract that from my total. So 12 minus 6 means I have 6 left to place. Now I can't put them on hydrogen. Hydrogen is already full. The only place I can put these is on oxygen. So to fill its octet rule, I'm going to go 2, 4, 6 on the oxygen atom. Those are my 6 electrons. I'm out of electrons. I'm now going to count. My hydrogens have 2 each, because remember, shared electrons count for both. Right, so hydrogens each have 2. They're good. Hydrogens only need 2. Oxygen has 2 from the bond, and then 2, 4, 6 from the lone pair electrons for a total of 8. That obeys the octet rule, 8 electrons. The carbon in the center has 2, 4, 6 from the bonds. But it needs 8. It needs to follow the octet rule. So how do we make it follow the octet rule if it's short? What we're going to do is we're going to make a double bond. The only atom here that I can pull electrons away from is the oxygen. So I'll take this pair of electrons away from the oxygen. I will draw them in between the carbon and the oxygen as another bonding pair. And now if I go through, my oxygen, 4 in the bonds, and 4 from the lone pairs for 8. Carbon, 2, 4, 6, 8 from the bonding electrons. Now everybody has their completed octet. Everybody is happy. This structure works. This is formaldehyde. And what I'm going to do here is bonded electron pairs. I'm going to replace these pairs of dots from the bonding pairs as lines. So I'm going to have carbon in the center, 2 lines to the oxygen representing a double bond, 4 dots on the outer oxygen. Again, I'm writing them in pairs. Do not write them solo. Bond to hydrogen, we're done. That's the Lewis structure. We are going to have lots and lots and lots of practice with this in class, so you will get very good at doing this fairly quickly.